when you split water, you remove electrons and protons from water. Those protons and electrons flow across the membrane and get recombined on the other side of the membrane to form hydrogen. That is your ultimate fuel source.
You can think of that device as bubble wrap that you would just get from the hardware store with the solar paint in it. Unroll the bubble wrap on your roof, feed in water, and out will come hydrogen as the fuel. The systems, you put them on a farm, you could put them on top of a factory building, put them all over the place to generate all of our energy forever from the sun.
So we've got hydrogen as a fuel, but what do we do with it? That's where fuel cells come in.
So we got solar energy in to our advanced solar panels of the future. They give us then the fuel, which is hydrogen. We then take that fuel and we put it into this other box, and out comes electricity. That box is called a fuel cell. So it's like a battery in the sense that you put your leads on there and you get electricity, just like in your car battery. But it's like a combustion engine in the sense that you put fuel in.
Fuel cells are definitely not a new technology. It's over 100 years since they've been known. Same time as batteries, sort of the electrochemistry was understood.
In fact, the first fuel cell was invented in 1839 by Sir William Grove. And since then, people have been working on fuel cells a lot. Inside of it, essentially, is two chambers, the fuel chamber and then the air chamber.
So we have hydrogen here, we have oxygen here, and we keep them separated by a membrane.
Now, here you potentially have water, H2O. And like boys and girls at a high school dance, they really want to get back together. And this membrane is basically just a sheet of a special material. And the way that our material works is that this membrane is what's called a proton conductor.
Only protons can go across, nothing else. Well, keep in mind that hydrogen really is just a proton plus electron. If that hydrogen can drop off its electron, it can now become a proton that can get through the membrane.
But basically, when the electron wants to go through, it's no, you can't come through here.
So the electrons go through some exterior circuit, and on their way, we make them do some work for us.
You got to turn on my light bulb. Okay, you got to make my computer work. You got to make my TV work. You got to make my stereo work. You got to turn on the heater.
Now the electrons go around, and at the same time, the protons are making their way across the membrane, and then on the other side of the membrane, the electrons, the protons, the oxygen all meet together, and we produce water as a byproduct. If hydrogen is used as the fuel input, then the exhaust is pure, clean water. We would absolutely not be adding to global warming in that scenario.
If you take a look at a fuel cell, essentially, it all boils down to what is this membrane material made out of, okay?
We were actually Susanna's first two grad students, number one, number two.
She showed us these particular materials that have what are called superprotonic phase transitions. And I was like, whoa!
It's a new class of materials which has never been investigated before. It's super protonic.
Yeah, it's super.
That's all I need to know.
That was the selling point, for sure. And then, we really worked on understanding the thermodynamics that make these materials do what they do. And we actually took the materials, smashed them together to make this special membrane, and created electricity from hydrogen. And right now, we're definitely doing this in a crude manner, but this is one of the things that we have to do to basically make this a highly refined commercial process. So you're basically making a sandwich. Membrane, and then we have hydrogen electrode and oxygen electrode. Think of them as pieces of the bread. And we've just smashed it all together. Go, Bessie. This is Bessie. Bessie the press.
She does all our hard work.
Big companies, they've been really pushing since the late 1950s to make a commercial fuel cell product. Why don't we have one? Well, the problem is that essentially that special material, that membrane, many different types of membranes they've used, but they all had basically an Achilles heel. Either not being very durable, or maybe having very low performance, or, and this is the one that pretty much kills them all, costing way too much.
Ours is the first new type of membrane in half a century.
Our mission is to get our fuel cells, into every household. One cell would power maybe your portable cell phone. But if you want more power, you put those cells together in what's called a stack. And that stack then gets put into your fuel cell generator and generates electricity for your home. You can use it in your car or at your local power plant to give power to your city.
Learning how to take water to a storable chemical fuel via sunlight is probably the grand challenge of the 21st century.
We're trying to really bridge that gap between innovation and commercialization. It's one thing to make it in the lab, it's another thing to make thousands of them reproducibly for commercial products.
I'm hopeful we'll figure it out, but we won't figure out something that'll be workable in the short-term future. This is a long-term goal.
We will indeed have to use fossil fuels. I mean, we're going to use it for the next 20 or 30 years because these solutions aren't happening in a time frame faster than that.
We got to keep plugging away at this problem with the smartest people we've got to see if we can see our way clear.
I mean, if you want to talk about security for the United States, well, how about making the United States totally energy independent and doing it in a way that doesn't harm the globe and impact global warming?
It doesn't matter how long it's going to take. It's something we have to do, because if we don't do it, the consequences are too dire.